Hello fellas and extraordinary engineers. This video is about a wonderful journey full of excitement and interesting stuff. Since March 2017, the team has started unstoppable work in order to fulfill the main qualifications of the competition. Let me first introduce you to our beloved team, Spirit. We're a group of enthusiasts, Wales City of Science and Technology students from 3 different engineering majors who share their passion of robotics and challenging conditions. The team is subdivided into 3 sub-teams. Mechanical, which is responsible for the main chassis and body design, analysis and manufacture. The electrical sub-team, which is responsible for the wiring and programming the main functions and electronics of the robot. And finally, the mapping and control team, which receives the output of the sensors and manipulate it to map the pose, velocity and angle of the robot, along with the mines found in the field, and then controls its movement accordingly with both automated and manual methods.
I am Hazem Al-Rifai, a member in the mechanical team. Basically, our design is divided into 3 parts: chassis, body, and arms. The chassis is made of 2mm L-beams of aluminium. We choose aluminium because it is light and stiff. An arrangement similar to the letter H provided us with extra space for the electronic components. This design also ensured the stability of the robot. The chassis is connected to 4 plastic wheels with grooves which are designed to accommodate different types of land. Then, the body is a simple design made of acrylic, designed to protect the electronic components inside it. There will be also 2 fans in the body to resist the increase in temperature inside the robot. Finally, the arms are made of wood. Each arm is divided into 2 parts, vertical part and horizontal part. This design will provide stability and decrease the vibrations in the arm.
Greetings, I am Omar Yasser and I'm going to talk to you about some of the components we are going to use in our robot. Sure, we are going to use the metal sensor to detect the presence of a metallic object. We are going to use with it an ultrasonic sensor to detect if the metal object is above the ground or not. To control the rotation of the motor clockwise or anti-clockwise, we are going to use the motor drivers. To help us with mapping, we are going to use encoders to calculate the distance from the rotation of the wheels. To minimize the error, we are going to use the accelerometer MPU 6050. To read the signals from some of the components and give orders to others, we are going to use Arduino Mega. And that's it. Thank you.
For the manual control of our robot, we wrote a LabVIEW code whose inputs are the directions from either the PC's keyboard or a joystick and the required speed level for the robot. It then communicates those pieces of information with an Arduino on board of our robot through a communication module. The Arduino in turn determines the required voltage together with its polarity that will be assigned to each of the motors on each of the wheels. But it's not just all manual. We're working on a separate system for an autonomous control of our vehicle. We aim at using a PID controller whose input values are dependent on the parameters we obtain from a mechanical model we're going to construct using Simulink. The output values are then fed to our Arduino code. For the mapping, LabVIEW was again used to provide a user-friendly interface of a map that not only displays the robot's real-time position on the field, but also marks whenever any of the metal sensors detects either an overground or an underground mine. The robot's position is determined with the help of a 1000 pulse per revolution encoder that, together with an IMU, allows for a great accuracy.